Hello, this is video O, and it's all about functions. Well, it's not everything about functions, but everything that's in the video is about functions. This is so important. How important is it? It gets a box rather than just an underline. And I'm sorry if I feel exasperated. This is the third time I've started this video. My electronic equipment is acting up again. I'm sorry. Distraction. Functions. So important. Definition. What is a function? A function. Yeah, I don't remember what I've said and what I haven't. And I'm going to go ahead and introduce my abbreviation, or FN, because functions are going to show up from now until the cows come home at the end of summer school, and I've got to write function on the board so many times. There you go. That's what it's going to look like from this point forward. A function is a, double quote, this is not the technical term, mini program. Aw, the cute little thing. Mini program that performs a specific activity. And the specificer, the better. Don't pile a bunch of stuff in one function. Have lots of little functions that do separate things. That's the ticket. That's the winner. For example, don't have, we wouldn't want a function that does the whole shebang and calculates the area of the pizza and the price and the tax and all that stuff. No. We would have one function that calculates the area of the pizza. Then maybe a separate function calculates the tax, yada, yada, yada. So small functions are a good thing. You might think, well, it's just a waste of time. But my goal is to prove that that's a misconception. That's not good. A function, moving right along, may receive, R-E-C-E-I-V-E, I before E except after C, may receive 0, 1, 2, dot, dot, dot. In other words, just any non-negative number, may receive values from the caller. I'm underlining caller. That is a technical term that's used. That's whoever tells the function, okay, you're on, do your stuff. That you call the function to do that. Function, it's your turn. Do your execution. So the caller will do that, and it returns, we've seen that word before. That's a reserved word in C++. And it returns 0 or 1. And those are the only options, not a whole list. 0 or 1 value back to the caller. I need to emphasize some more words a little more here. A function may receive, coming in from the caller, it will receive some number of values, however many values it needs to be able to do what it needs to do. And then it turns around when it's done and sends back either exactly one value, or it doesn't send anything at all in some special cases. Most of the time, it will send back exactly one value. And it returns, that's one double underlined word there, returns a 0 or 1 value back to the caller. Okay? Now then, the format for a function. You know what? I'm going to put this down here. I hope that's okay. So I can leave that there until I get finished with the format. And then I'm going to describe the, I don't know, I'm planning out how to use a whiteboard in my head, and it's all going to fall through like everything else has today. Okay, out in front, we've got a return type. In pointy brackets, first piece of the format. Then at least one space. Then the function name, there's my abbreviation already, FN for function. Function name, in pointy brackets. Then an open parenthesis, and it's an actual literal open parenthesis. I'm going to make that big and bold. That's not a symbol representing something else. That is itself. It's an open parenthesis. And then inside that, pointy brackets, what's called the formal parameter list. Holy moly. It's even a big, complicated sounding symbol. All that in pointy brackets. Then closing parentheses. There we go. Then underneath and indented in pointing brackets, the function body. Even the format looks complicated, doesn't it? Some of the functions, I think, are easier than the format description itself. Why did I put that way down there at the bottom of the board? Because I'm going to erase this and elaborate or explain what all those pieces are up here. We already know it's video O. Did I say 0? I didn't mean to. It's video O. Ain't no video 0. Okay, to distinguish the description from the format, I'll switch colors and hope that this works. I didn't test them all in advance. Elaboration. Yeah, that was great. That was really juicy. Elaboration. Return type. I bet you could reverse engineer a reasonable description of return type all on your own, but I'll insult your intelligence and say that the return type is the type of value returned to the caller. And remember, I guess until further notice, we'll just say the caller is the main program. The main program's doing its business. You know what? I don't want to have to do this calculation. I'll make a function do it. So the main program calls the function, and the main program just sits there and waits till the function gets done. And then the function will eventually finish, for crying out loud, and return a single value back to the caller, the main program. Getting a little ahead of the game. What? Oh, this may be, I'm not going to list all the possibilities. Here's some of them. Int. We know integer is a data type. String. What else we got? Double. Bool. Comma, dot, dot, dot. Because I left out others, any data type whatsoever. Or, wait, there's more on that as well. Or, void, if no value is returned. Void is a special reserved word that means nothingness in devoid in C++. Nothing. So if the return type out in front, before the function name is void, that means we're not going to send anything back. Don't sit around and wait for me to send you something because you're not getting it. Okay, all of that was just for the return type. The next piece is the function name. I better back up over here. I'm not going to have space. Function name. That's the name of the function. Okay, a little more technical than that. This is the identifier, I-D-E-N-T-I-F-I-E-R, used to call the function. Main program can't call the function if it doesn't know its name, the function name. The identifier used to call the function. And I won't take up board space, but I'll say it. It follows the same conventions as variables. So it's camel case, it starts with a lowercase letter. There, you can remember that, can't you? I hope. The biggie one, the formal parameter list. Colon, even gets a big colon. This is a list of variables. They have to be variables, can't be symbolic constants, can't be literal values. A list of variables. What's special about that receive their values passed in from the caller? I'm going to say will, act like it's in the future. Because when we type in the function, it's not even necessarily going to execute. It won't execute until the main program calls it. So a list of variables that will receive their values, and I'll use the term that's used, will receive their values passed in to the function, passed in from the caller. I'm underlining, double underlining everything, good grief. I'm crying wolf. If everything's important, then nothing's important. But still, that's very important. A list of variables that will receive their values passed in from the caller. Could be worse. I could be writing everything all in capital letters. And you might wonder why formal. I mean, that it doesn't sound very formal, does it? White tie, a high school formal or whatever. That's formal in the sense like an income tax form or a job application form. There are a lot of blanks to be filled in. And that's a healthy way to think of this. This is a list of variables that are like blanks in the function that have to be filled in before the function knows what numbers or what strings or whatever it's supposed to be using. When we have a function, which we're going to have in just a second, when we have a function that calculates the area of a triangle, you got to fill in the blank for the base and fill in the blank for the height, or the function's not going to be able to do its job. I mean, it's not going to be able to figure out what the area of the triangle is if you don't give it values, if you don't pass in values from above down to the function. And we're almost there. I was very stingy with board space, and it paid off. The function body function body is a statement block, STNTBLK, abbreviated. What is a statement block? That's a sequence of statements enclosed in curly brackets. We know that from a long time ago. A statement block that contains the local, L-O-C-A-L, local variables and underlining again, man. Today is underline day. A statement block that contains the local variables and executable statements of the function. E-X-E-C-U-T-A-B-L-E. Executable in the sense that stuff like assignment statements, arithmetic, an if maybe, an else maybe, those are executable. Those are activities to do. In addition to local variables. Local variables are like the scratch work variables that a function needs to be able to do its job, but the main program doesn't have any business using them. And again, all of this will make more sense, I hope, when we start looking at some examples. For example, it came to me again. Any questions so far? See, I can't get over old habits. I'm going to see if I can squeeze in the beginning of an example. No, I'm not. I'm going to just get rid of this down here. We've covered the format. Been there, done that. So, here's an example. Example from math. This ain't a math class, but we can't escape it completely. Sorry about that. The area of a triangle. Get down there. Area of a triangle. We know that, don't we? I hope. 1/2 times base times height. Now, no, that's not C++ yet. It's not even close. But that is the formula, like we could use formulas to calculate temperature conversions or whatever. That's the formula for calculating the area of a triangle. Or another way to write it that's a little closer to what we need, I'm going to put out front area and then put in parentheses area base comma height equals 1/2 times base times height. Oops, I almost put a C++ times there. X for mathematics times. Now, why did I rewrite it like that? What this is saying is, I can tell you the area. I can give you that if you give me these two. I am an area calculator. Yes, I am. All you got to do is provide me with a base and a height, because area is a function of the base and the height of the triangle. It depends on those. So it is a function of those. If you want to know the area, you got to give me the base and the height. So it's a give and take situation. You give me these. You tell me what the base and the height are. I'm going to do my little math over here in the scratch area and send you back the area, and I'll tell you what the area of your triangle is. It's a deal. Okay, now, Again, inefficient use of board space. That is our mathematical motivation. Let's see what this looks like in actual C++. An actual C++ function written on the board. I haven't been writing code on the board very much, have I? In C++, I'll put a comment in C++ for emphasis. Double, D-O-U-B-L-E, might not be a whole number. Double out front and then triangle area. In parentheses, I'll go back and explain these pieces after I write them up here. Double, base, comma, double, height, running perilously low on board space to the right, but just in the nick of time, close parentheses and open curly bracket. What have we got so far? This is actual C++. This out front, if you remember the format that I erased, there it is right there. That's the return type. So the thing that we're going to send back to whoever called us, triangle area, I need to know the area, here's triangle. Whoever called us, we're going to send them back a value of type double. 3.5 or 100.9 or whatever it may be. What's the next piece? The function name, the triangle area. If the main program wants to use this function, it's going to have to use that name. It's going to have to spell it right, too. Formal parameter list. Now, here's the biggie. Here's one that perhaps takes the most getting used to. This looks a lot like a list of variables like we might have at the top of the program, where we say, okay, this is my toolkit here. These are the variables I'm going to be using in the program to do my calculations and to hold the values read from the keyboard, yada, yada, yada. It's a little different here. For one thing, we can't just say double, base, comma, height and get a whole bunch of variables done at one time. Every parameter, these are called parameters, base and height are the parameters to the triangle area function. Each one has to have its own data type specifically laid out, and they also are separated by commas rather than semicolons. So it really is a list. It's a list inside parentheses. Any number of parameters, any number of blanks that we want the main program to fill in can be put inside these parentheses here, but the main program has got to make sure it sends us that many, and it's also got to make sure it sends them in the right order. They're going to match up one-to-one as it goes through the list, and we'll see that when we finish the example in a second. But in this particular case, that means the main program is going to need to know, send in the base first, and then send in the height, and don't try to send in anything else. And don't try to send in just one number. It's got to match this. These are the blanks that have to be filled in before we can do the job of the function body, which is where most of the action happens. Double, I'm indenting because I'm inside the curly brackets, double area, semicolon. And then some calculation. Area equals 1/2, but I write 1/2 as 0.5 times, and that is an asterisk, a C++ multiply, times base times height. That's an assignment statement, needs a semicolon. And our work is done. Let's go back where we came from. Return area, semicolon, close curly brackets. There it is. I'll put a big set of square brackets around it. That is a complete function. I told you it was a mini program. That's pretty miniature, all right. Someone's got to tell it what the base and the height are. As soon as we tell it what the base and the height are, it sets up this local variable. You know what? I'll put that as a different color comment, since this is the very first local variable we have officially seen in this course. Local variable. What makes it local? Well, a couple of things. Clearly, it's inside the curly brackets. The implications of that are nobody outside this function can see this variable. This is our private variable. No one can touch it. They can't print it out. They can't read it in. They can't change the value. Not nothing. That's one implication of it. Another implication of it is your eyes deceive you. Just typing this in does not make a variable named area. Unless the main program gets around to calculating a triangle area, unless it calls this function, this variable will never exist. When this function is called by the main program, it's like Brigadoon. All of a sudden, all the local variables and everything spring to life and dance for joy on the Irish countryside or whatever. But double area does not exist in memory until this function is called. And as soon as we hit the closing curly bracket down here, just in the nick of time, we return the value of area back to the main program. Because as soon as we get out of here, as soon as we hit the closing curly bracket and we've returned to the main program, variable area no longer exists. It might sound like that's fraught with disadvantages, but it's not. It's actually a good thing. What that means is, maybe this is part of our own math library we're writing. We're going to have triangle area, and square area, and circle area, and trapezoid area. Every single one of them can use the same variable name if they want to, and none of those variables have anything to do with each other. They're all blissfully unaware of each other, because each one of them, if we set it up like this, each one of them only exists while that function is running. And we don't accidentally have multiple variables with the same name. They are very, very different variables with the same name. Now, I'm going to say that I did this on purpose, but actually it's kind of a happy accident. I'm going to get rid of the purple stuff up here, because it might be bothering you that you might go to all the trouble to type that in, and it doesn't run at all. That function will not run unless it is, what color is that? That's the same color. This function will not ever run unless it is called by somebody, the main program or maybe even another function. But I'm going to say up here, this is the main program that we know and love. We've been doing main programs ever since we started C++. That's nothing new. But in this case, it's playing the role of the caller. That's the one that's going to call our function. And has to call it by the correct name. Yada, yada, yada. And it's got to set up a variable, perhaps. Well, not perhaps, absolutely. Double my try area. That's the name of the variable. I want it to put the area of my triangle in that variable. But I'm too lazy, or I don't understand the formula. I don't know. I'll let somebody else do the actual calculation. So I can say my try area, if I can spell it, equals, and then I call the function. The right-hand side of an assignment statement now becomes an expression that's evaluated. I'm going to write this up here, and then I'll say that again, because that's an important idea as well. Triangle area is the name of the function. I'm going to make it easy on myself. 10.0, comma, 6.0. If I can't do that math, I'm in trouble. Then I close parentheses, semicolon, and just make sure it did what it ought to. When I get back, I'll print it out. C out, less than, and I'll abbreviate it, just call it area. We know it's a triangle. Close double quote, less than, and then the value of my variable, my try area. End all. And ... on about our merry way. Now, all my markers are going to dry out. I keep losing lids. So it's just like the real classroom. Now I want a very noticeable color. Here's a very noticeable color. Here's my trace over here to the side. I only got one variable to keep up with. My try area. Initially garbage. What's the next thing that happens? Well, I'm going to number these steps one at a time as they go. I set up the variable as garbage. Now, when we get to an assignment statement, repeat along with me. It starts on the right-hand side before it even looks on the left-hand side. Well, how's it evaluate that expression? That doesn't look like an expression. That's some kind of weird business going on over there. That, ladies and gentlemen, is a call to our function down here. So what this is doing, this will be step number circle 1 in a circle. This is calling the function. I'll just draw an arrow right there. Wow, just take a shortcut. It's calling our function down here, which means, here's what it means to call it. When it hits this, the call of the function, it leaves the main program. It's just dormant. We're not finished with the main program. We didn't crash it or anything, at least not yet. It leaves the main program and comes down here and starts executing a little program with a life of its own until this is finished and goes back where it came from. The main program is just sitting here waiting. It doesn't have anything to put in this variable yet. It's got to wait and see what triangle area sends back to it. Now there's more stuff going on than that. This is a positional parameter list. Those are actually called the actual parameters. Those are the actual real live numbers I want it to fill in these blanks with. So I'm going to have arrows galore here. I apologize for that. But this is actually a call to this function. There's arrow number 1 corrected. This 10 is going to base. And you guessed it, that 6 goes to height. Okay? Oh no, I started a trace and I didn't put the variables over here. That's not an oh no. I was feigning oh no-ness. Those variables don't exist. Even base and height, those are local to this function. Those variables are not carved out of memory space until this function call occurs. When the function call occurs, we get 2 brand new variables, base, height, that had never seen the light of day until just this microsecond, this nanosecond, and we don't even initialize them to garbage. These are receiving messages passed in from above. Base gets the value 10.0. Height gets the value 6.0. Okay? So 1, this call down here, that brings us down here to step 2, which I'm going to say or claim is let the execution of the function begin. It's all set up. We left the main program behind. This purple stuff, it's dormant. It's still sitting there in memory. It didn't go anywhere. But it's not going to do anything. It's not going to go to the next line until this runs completely from top to bottom. So here we are. We've got base with a 10 just now filled in, height with a 6 just now filled in, and then this cuts the cord with its parent up there in purple, the main program, and takes on a life of its own. This gets the undivided attention of the CPU. Its bright and sparkling moment in the sun until it's done. The CPU is not paying attention to anybody except this function until it's completely done. Now here's a weird thing. There are actually 3 brand new variables carved out of storage when this function is called. The other one is called area. It did not exist until just this microsecond. But unlike these 2, this does not receive anything passed from above. This is a local variable. It's almost, well, it's not almost, it is hidden inside the curly brackets for the function. So that does have a garbage value initially. Uh-oh, here comes, I feel good, I feel strong, I think I can do this. An assignment statement, it's got to evaluate the right-hand side. 0.05 times base, also known as a half. A half of 10 is 5. 5 times height. 5 times 6 is 30, right? So 30 becomes a new value of area, 30.0. Okay, that'll be my step 3, execute from top to bottom. I don't know what these steps are really corresponding to, other than to show you the order of operation here, the order that things are happening. Number 1 was, okay, let's call the function, send in stuff. Done. Okay, 2 is we land in the function and get all our variables all set up and we're ready to go. 3 is we actually do it, we're ready to go. Now what? When we're done and we hit the return statement at the bottom, then it grabs the value of area just in the nick of time. And I'll show you why I mean just in the nick of time. I'm not sure I can get there from here. Oh, well, I wove through purple code up there. I'm going to weave through black code down here. The value of area, since we're returning that, goes back to the main program and becomes the value of this expression on the right. So this goes back up, this 30.0 we just now calculated, that goes back up and becomes the value. You can think of it as it replaces the function call with the return value that's sent back. So it's like we pull out the triangle area 10 and 6 and replace it with 30.0. So the right-hand side now, the 30.0, I told you I was going to have to go through some code here. That's step 4. Step 4 is the 30 goes all the way back up here. So here, let me label these. 10.0 got sent down from above. 6.0 got sent down from above. Landed right here in our 2 parameter variables, formal parameters. Those are blanks in a form that have to be filled in before we can continue. And then it defined a local variable, did a calculation, yada, yada, yada. It finally hit the return statement and goes back up here. So now we're back up here. The 30 came back. The main program wakes up. The purple statements are going to pick up where they left off. Where did we leave off? Well, when last we saw the main program, it had just called the function. Now the function is done. It executed top to bottom. It's completely finished. Comes all the way back up here. And the 30 is the value of this and becomes the new value of my triangle here. So it's not garbage anymore. It's 30.0. That was step 4. Step 5 is we actually produce some output here. 5. Area, colon. And even though the main program didn't calculate any area itself or anything, it leaned on the function to do that. There is the area of that triangle now stored in that variable, area 30.0. That's it. That's the whole function. What if, here's a what if. What if I'm having trouble with my function and I want to double check and see what the area is before I go back? Well, there's no rule. It's actually a conventional rule. Don't do any input or any output in your function unless that is the job of the function. If I have a function named display triangle area, then it's okay for it to print to the screen. If I have another function called read triangle base, then that can read from the keyboard. But one like this that's doing a calculation, this one doesn't have any business printing or reading anything from the screen. This shouldn't read base or height from the keyboard. This should not even print the area when it's done in the final version. Why? Because as soon as we customize it and say, here is your area, then we have severely limited the reusability of the function. Customization is great for Italian sports cars. It'll kill C++ functions. If we start customizing this stuff to one particular application, then all of a sudden we've broken its usefulness for anything else. All of that is a disclaimer because I'm going to stick a cout statement in here anyway. Cout because I'm getting bugs and I don't understand from where. Area, colon. I'll just go ahead and print it out down here before it goes back and make sure it's right down here. Area. Won't even bother to put an inline. I did that on purpose. Now, karma. I told you it's bad to put couts down here. That's not the reason, but that cout, when this executes the steps 1, 2, 3, 4, 5, that cout will never print out anything. How come? Because as soon as the CPU hits a return statement, boom, you're gone. You went back to where you came from. That's exactly what the return statement does. It says, get me out of here. Go back to whoever called me. In this case, it goes back to the main program. So it's as if, now, here's the strange thing. Most compilers don't even warn you about that. Some will. Some will say, you got unreachable code in line whatever. That just means the CPU will never execute this. It will never see it. The reason it will never execute this is because it's past a return statement. So it's as if that line's not there at all. If I wanted to print out area, I would need to do it before the return statement. Some of you have found that out the hard way. And by that, it might not even ring a bell with you. By that I mean, if you put a cout statement, debugging statement, or whatever in your main program, after the return 0 at the bottom, it never printed anything out. It didn't crash the program, but when you say return 0 in the main program, you're sending a 0 back to the operating system. Whoops! The curtain opens, the secret is revealed. We've been using functions ever since we started C++. Int main void is a function that's called by the operating system. It does all its stuff, whatever you tell it you want it to do, and returns 0 to the operating system when it's done. Visualize this with me, won't you? Int main void. The int says we're eventually going to return an integer, which we do. We eventually return a 0. Main is the special function name that the operating system knows it's supposed to call to execute your program. It's not executing a program as opposed to a function. It is executing the main function. Void means we don't get anything passed in from the operating system. We're going to have to do whatever we're going to do with stuff we read from the keyboard or calculator or whatever. But the main program really is just a special case of a function. I didn't mean to blow your mind. That just occurred to me. Okay. What a mess I've made. I'm going to have to clean the board anyway, because there's some stuff I need to write. Not a whole lot. Just kind of some observations. Maybe you already figured these out. Maybe you didn't. Notes. Notes number 1. What is it? A function is only executed if it's called. Only executed, abbreviated executed, if it is called. Just because you type it in your editor and it compiles cleanly with your compiler and links with your linker and runs when you tell it to run, just because it's present in your source code file and became part of your machine code doesn't mean it's going to execute. You have to call it or it won't be executed. And for examples, I guess, I'll call these examples. They're not really called 5 times. What is this? Well, maybe it's in a loop. Maybe it's in a for loop that executes 5 times. Then the function is executed 5 times. Of course it is. Or wait, never called. In other words, called 0 times, then never executed. If you want to make sure your function does what it's supposed to do, then you got to make sure that you call it somewhere. Otherwise, it's not going to do anything whatsoever, and you won't know whether you've got your logic in it correct or not. I should have left more space, and I am going to get a juicier marker for note number 2, because this probably deserved to be more than just a note. 2. A function. This is a big one. A function needs what's called a prototype. P-R-O-T-O-T-Y-P-E. Scary sounding word, but it's actually pretty simple. A function needs a prototype at the top of the source file and you'll recall the source file is what you type in, so that's just what it's saying. You've got to type this in at the top. A function needs a prototype at the top of the source file so that the compiler can check that calls to the function are correct. Calls to the function are correct. I mean, they're set up correctly. They've got the right number of things in parentheses. You're sending enough values to fill in all the blanks, all of the formal parameters inside the parentheses. It can check that. It can check and make sure that you're storing the return value in the right kind of variable, all that kind of stuff. And you might think, well, how on earth am I going to make one of those? This is actually usually one of the last things I do. You can do this after you've already written the function. Here's a comment. Same as first line of function, comma, but ends with semicolon rather than an open curly bracket. And I'll let you write instead of an open curly bracket if you want to. It's the same in the first line of a function, but it ends with a semicolon. For example, for our triangle area, I think we could do this. Double space, triangle area, open parentheses, double base, double height, after a comma. Close parentheses, and if we were actually writing the function itself, here we would open a curly bracket and do all the statements that go inside. Make a local variable for the area, do the math, all that sort of stuff. Here, all we need is the first line, and you might think, well, what on earth? What good is that? When you put that at the top of your source code file, you are doing what's called declaring the function. I do hereby declare that even though you haven't seen it yet, Mr. or Ms. Compiler, there shall be a function called triangle area, probably near the bottom of the source code file. Don't sweat it right now, it'll show up. But there will be a function that's called this. It will send back a value of type double, and it needs two values of type double passed into it, or whatever the variable data types need to be for your function. All of this goes off in a mental note to the compiler. This doesn't turn into machine code. It actually makes an entry in what's called the symbol table. It's like the compiler's little scratch area. So that later on in the main program, when it runs into a call to triangle area, the compiler can check its notes off to the side in the symbol table and say, well, let's see here. Is that call set up correctly? Does it have two parameters? Are they both type double instead of something weird like string or whatever? Are they storing the return value in a double variable? Okay, clear to proceed. That call is set up correctly. So that's precisely what prototypes are for. So the compiler can help you, help yourself, by double checking and make sure your functions are called correctly. Okay? Now, I don't know that there's any need to erase right now, but my notes say look at example6.cpp. Look at example6.cpp. I hope it's attached to this email. Who knows anymore? But anyway, if you look at example 6, let me see. I printed mine out too finely. There is a prototype on line 21 that I think matches the one on the board exactly. Yes. The prototype says, I hereby declare there shall be a function somewhere called triangle area. It's going to return a double value, and it wants two parameters passed in, a double base and a double height values. Now, those don't have to be variables. I might have misspoken and said it needs two variables passed in. All it needs is two values passed in, each of which is type W. Type double, not W. I'm sorry. It's late in the afternoon for me. The caffeine's already worn off. Look at line 39. Inner triangle base, inner triangle height. Line 39 passes in just the two variables that were read in from the main program. Now, the example I wrote on the board, that used two literal values. I just filled in the numbers. You can put absolutely anything under the sun inside parentheses as long as it's the right data type, and it will get sent down to the function to use as the base and height. In this case, it's whatever the user typed in for try base and try height. We pass that in, and then when we get back on line 40, it turns around and prints it back out. Now, line 40, you know what? I'll come back to that. Let me finish talking about triangle area. Line 43 is another call to the same function. Aha, we discover one of the big advantages of using functions. You can use them over and over and over again. Pass in different values to calculate different triangle areas. Anywhere you want to. The second time, I wanted to know the area of a triangle that had base 11.111 and height 22.222. So that's what I used in my call. Oh, wait, I want another triangle. 47. I passed in two symbolic constants. Now, I just now realized it looks like, well, it's got to be two variables, or two literals, or two symbolic constants. That's not right. I can mix and match. And I kind of did that, I think, on line 51. I was just trying to think of weird special cases. 51 is also calling triangle area, and it's passing in expressions, base plus 10.01. The compiler will actually go ahead and calculate that, and then it will know what to send. Oh, not the compiler, the CPU, when the program's running, will calculate that and pass that value in to fill in the value of base. And then the second one is even more convoluted, try height plus try base divided by 2, and it sends that in as the second parameter. What am I trying to browbeat you into understanding there? That the actual parameters that you send in, those can be anything under the sun as long as they're the right data type. The variables in the function, though, those have to be variables. It wouldn't even make any sense to put literal values here, already filled in. It wouldn't make any sense to put symbolic constants because those are not blanks to be filled in while the program's running after the function's called. The only thing that makes sense here is that these have to be variables that are going to hold. Those are blanks that filled in. Those are going to hold the values passed in from the main program. Okay, that's all the calls to triangle area. And where's the function? Oh, the second page on mine. The function itself starts on line 101 with the documentation. Calculate the area of a triangle given its base and height. And that, I hope, is exactly what I wrote on the board. Now, while we're looking at functions, and it's on my second page, I'm going to just kind of give a quick overview of these and why I decided to put those example functions in there. And then you get to practice tracing those, the calls from the main program. I would even recommend that you make the local variables when the function's called, fill them in, and just it's excellent Practice for your tracing skills, which you do desperately need, I desperately need, the American people desperately need. The first one on line 86, get true false is returning a Boolean value. It's returning true or false. The unfortunate, sad nature of Boolean values is you cannot read a Boolean variable's value directly from the keyboard using cin. You have to kind of fudge it or fake it. So if we want them to type in true or false, we got to write a function and read that in as a string, and that's exactly what's going on. But if you look through that function, yes, it reads a string. It returns true if they typed in true. It returns false if they typed in false. It makes them go over and over again until they finally type in true or false. Otherwise, they get stuck in an infinite loop. But that's, believe it or not, that's not even why I included that function. I included that function because that's an example of one with a void parameter list. This one's job, its only job, one and only job, is to read from the keyboard a value of true, lowercase, or a value of false, lowercase, and return that as an actual Boolean value. For that, it does not need anything passed in from the main program. And it certainly has no business printing out things like, are you over 50 or whatever. In other words, the extra additional extraneous output would only break this function so that we can't use it whenever we want to read a Boolean value from the keyboard. As it is, it doesn't know what question is being answered. And that's exactly the way we want it. It might sound ironic or even silly, but the more ignorant our functions are, the more useful they are. Everybody loves an ignorant function. Who else is ignorant? Get string between on line 112 is ignorant. Get string between is doing input validation. Someone's going to pass in a string little and a string big, and we read a string, and we've seen structures similar, not structures, but a logic similar to that before, where we have a while loop that makes them type it over and over until they get it right. So that kind of gives away the secret of what that function's doing. One more, why is there a function on line 125 print triangle message? Well, that's an example of a function that doesn't return anything. The only reason for the existence of function print triangle message is to take the ugliness of a big, ugly, complicated cout statement out of the main program and bury it in a function, just to simplify and streamline the main program, but it doesn't need to return anything. All it's going to do is print out the base and the height and a message about the area, and you see it in action in the output on lines 134 through 137. Now, does that cover every possibility of functions? Oh my goodness, no. Absolutely not. We're barely scratching the tip of the iceberg. But even though I didn't elevate these to being covered in a video, I do want you to read through these carefully, because I might very well bring these up on the agenda in one of our Zoom meetings. You've got to be able to understand functions. You're going to have to be able to write your own. All other kind of warnings I can possibly give you, but that's it. That's it for now. That's the intro to functions. Don't know what else to say, except see you online. Bye.